So what is 1 cubed? What is 2 cubed? 3 cubed? 4 cubed? 5 cubed? 6 cubed? 7 cubed? 8 cubed? 9 cubed? 10 cubed? 11 cubed?
I don't know. 1, 2, 3, 1.
It is actually, yes. Okay, 1,331. And yes, I did that just because y'all were reading the ones off the board, and so I wanted to at least make you think on one of them. All right. So now, we are going to look at the perfect cubes. These are the ones that we can evaluate to get a whole number, okay? What is the cube root of 8?
4.
2. Because 2 times 2 times 2 is 8.
That's what I meant to say.
Okay, now, what is the cube root of 729?
9.
What is the cube root of 1,331? All right, for the cube root of -1, what is that?
1.
-1. Okay, it is -1 because -1 times -1 is +1. Times another -1 makes it -1. Okay, so a square root, you cannot take the square root of a negative number because there is never going to be a negative times a negative that equals a negative, right? But whenever you have a negative times a negative times a negative, it can be negative, okay? So we can have negatives with cubes, but not with perfect squares. Now, what is the cube root of 27? What is the cube root of -343? Yep, it is -7. Okay, now we are going to go ahead and we're going to look at simplifying non-perfect cubes. So we do this the exact same way we did squares yesterday, okay? So what we do is we look to find the biggest perfect cube that goes into the number, okay? So what is the biggest perfect cube that goes into 40?
2.
8. And 8 times what gives you 40?
5.
So we have the cube root of 8 times the cube root of 5. What is the cube root of 8?
2.
So we have 2 times the cube root of 5. We take the part we can take the cube up and leave what we can't. Okay, now for 26, we have the cube root of 500. What's the biggest perfect cube that can go into 500? 125 times what? 4. Okay. What is the perfect cube, or what is the cube root of 125? Okay. Can I take the cube root of 4? So we get 5 times the cube root of 4.
Can we get to the other one for a second?
Do what?
Can we get to the other one for a second?
Yes. All right. For 27, we have the cube root of 162. So for a second, let's talk about how you would go about finding this. Okay? You're looking for the biggest perfect cube that goes into 162. When I say goes into, I mean the biggest one that 162 is divisible by. It will not be one of the numbers bigger than 162. Okay? And then you just look. Does 125 go into 162? No. Does 64? No. Does 27?
Yes.
How many times does 27 go into it? Okay, so we rewrite it as the cube root of 27 times the cube root of 6. And then we take the cube root we can. So what's the cube root of 27? So we have 3 times the cube root of 6. Then let's look at 28. So for 28, we have the cube root of -16. When we have a negative cube root, we are going to bring the negative out, okay? Then what is the biggest perfect cube that goes into 16? And it's 8 times what?
2.
That gives us 16. So we have negative. What's the cube root of 8?
2.
Times the cube root of 2. So negative 2 times the cube root of 2. All right, 429. Okay. We have the cube root of 432. What is the biggest perfect cube that goes into 432? Okay, so we do 216 times the cube root of, and what is the cube root of 216?
6.
So we get 6 times the cube root of 2. All right, for 30, okay, we take out the negative. What is the biggest perfect cube that goes into 320? 64 times what? And what is the perfect cube of what is the cube root of 64? Times the cube root of 5. We just took the cube root of 64. Yep. All right, I want you to do 31, 32, and 33 for me real quick. Yeah. Yeah.
I was trying to do my but I didn't know how to put a
Shift 6.
shift 6. Okay.
Gives you a square. All right. Whew. Once you get those 3, you can check your answers. All right, so the next thing that we're going to look at is we're going to look at how to simplify square roots with variables in them. Okay. Upon first glance, that kind of looks more complicated, but it's actually less complicated. Okay. So, whenever we look at a square root, if we are looking at a square root with a variable in it, all we have to do is we take a look at what the exponent is of the variable. Okay. So, for this right here, we have the square root of a to the power of m, right? To find the square root of that, all I do is I take a, and it will be to the m divided by 2. We just have to see if this exponent is divisible by 2, okay? Because when we are dealing with squared exponents, it's just things that are being raised to the power of 2, right? So if it is divisible by 2, we can take it out. If it's not divisible by 2, then we have to look at it. So we're going to start with these first 2 examples here. So we have 34. So this is a square root. Is 2 divisible by 2?
Yes.
Okay. So how many times can 2 go into 2?
1.
So we have x to the first power. And do I have to write to the first power? It can just be x. Yeah. Okay, did you have a question? You raised your hand. Okay. Now we're going to look at 35. Okay, for 35. Again, we know this is a square root. Is 6 divisible by 2?
Yes.
How many times can 2 go into 6?
3.
So the answer to this would be m to the third. Okay, now we're going to, over here to the side real quick, okay, we're going to do a couple of examples where x doesn't go in perfectly, okay? So if we have the square root of x to the third, so we know we are taking a square root. Is 3 divisible by 2? No. But how many times can 2 go into 3?
Once.
Okay, it can go into it one time, but with how much left over?
Twice.
So it can go into it one time and then it has 1 left over. And that's where we get those numbers from. Okay, so if we look at it again, if we look at the cube or the square root of x to the 7th, okay, is 7 divisible by 2? No. Okay, but how many times can 2 go into 7?
3.
And how many would be left over? And so that's all we are doing when we're dealing with exponents. We just see how many times it goes into it, and then what's left over.
So the leftover, if it wasn't going to be the extra for the
And we'll see some of those when we look at cubes. All right, now we're going to look at the back, and we're going to go to question 36. All right, for question 36, we're going to look at what to do when there's multiple things happening at once. Okay, we have a 9 and we have k squared. What we can do is, I want you to look at it as separate pieces. So the square root of 9 times the square root of k squared. What is the square root of 9? 3. Now, we have the square root of k squared is 2 divisible by 2. How many times does 2 go into 2? So we have k to the 1, or just k. And that is our answer. All right, for 37. Okay, we're going to split it up. We have the square root of 64 and the square root of p to the 4th. What is the square root of 64? Okay, then we're going to look at the square root of p to the 4th. Okay, is 4 divisible by 2? Okay, how many times does 2 go into 4? So it will be p squared. All right, for 38, okay, this has 3 pieces. So we're going to do the square root of 100, the square root of x squared, and the square root of y squared. So I want you to take a second and finish that problem for me. What'd y'all get for the answer of that one? 10xy. All right, now we're going to look at 39. So for 39, again, this one has 3 pieces. We have the square root of 63. We have the square root of x to the 5th. And we have the square root of y to the 14th. Okay? To take the square root of 63, does that have a square root? But what's the biggest perfect square that goes into 63? 9. And it's 9 times what?
27.
Okay. Then I'm going to go ahead and simplify that. What's the square root of 9? So we have 3 times the square root of 7. Okay, that's the first piece. I do piece by piece. Now, we have the square root of x to the 5th. Is 5 divisible by 2? No. But 2 can go into 5 twice with how much left over? All right. Then, is 14 divisible by 2? And so how many times can 2 go into 14? 7. Okay, now, so these are the pieces that we have to combine, right? So what we do when we have to combine those pieces, what is outside of the radical is going to stay outside of a radical. What is inside of a radical will stay inside of a radical, okay? So if we look at these, the pieces that are outside of a radical are 3, x squared, and y to the 7th. So we're going to start with just writing 3 x squared y to the 7th. Okay, then we're going to put our square root in there. And we're going to put everything that's under a square root. So what all are under a square root here? Or just 7 and x, right? So it'll be the square root of 7x. So if it's outside of the radical, it will stay outside. If it's inside, it stays inside. And you just multiply those parts together. Okay? For 40, why don't y'all try to do 40 for me? And 41, just for funsies. All right, so for question 40, what is the answer? What was that? 3y to the what?
Oh.
And then the square root of? Okay, because we break apart the square root of 27, we get 3 root 3. Can we break apart the square root of x? No, so it stays under the radical. Then we break apart the square root of 6y to the 16th power, which gives us y to the 8th. So outside of our radical, we have 3 and y to the 8th. Then inside of our radical, we have the 3 and the x. Has anybody done 41 yet? I'll give you a second. What's the biggest perfect square that goes into 252? 36 is correct. And it's 36 times 7. So you do get 6 root 7. It just keeps haunting me. It really does. It won't go away. What was that? Oh. Oh, we got an email. That's why.
So you can go ahead. No, what? I didn't want you to watch me do it correctly.
Whoa, you can't just drop that. I got fired.
I remember 16, I'll be
It was the most random class too, but like.
So, my mother sent me like a ton of pictures from my dad's trail camera because she thinks that one looks spooky. And I think she's crazy. It's just a bird. It's just a bird. But she sent me like 12 pictures from his trail camera because I was like, oh my God, my mom texted me like 12 times. Is there an emergency?
So it's spooky in here.
No. She just sent me like 12 pictures of a bird in the woods.
Wow.
Nice going.
All right. So for 41, okay, we break apart the square root of 252 to get 6 root 7. Okay. Then we cannot take the square root of x, so it stays the square root of x. We take the square root of y squared to get y. And if we take the square root of z to the third, we get z times the square root of z. Okay? For which part? So 2 can go into z one time with 1 left over. So we have the z times the square root of z.
Oh, okay.
And then the outside part stays outside. And the inside part stays inside.
I was like, oh, I feel one time.
Oh, okay, that's fine. All right, now, cube roots with variables, okay? If to find the square root, you divide the exponent by 2. What do you think you do with the cube root?
3.
Divided by 3. So right here, we're going to we're going to put in the cube root right there. And we're going to do a to the m divided by 3. Okay, that is what we are checking on these. And we're going to look at 42. So for 42, is 3 divisible by 3? How many times can 3 go into 3? So we have m to the first power, or just m. All right, for 42, or for 43, okay, we have the cube root of 8, and we have the cube root of x to the 6th. What is the cube root of 8?
2.
What is the cube root of x to the 6th? So is 6 divisible by 3?
Yes.
How many times can 3 go into 6? So we get x to the 2nd. Is there any left over? Nope. And before we look at any others of these, okay, I want to do a quick example. So we have the cube root of x to the 5th, okay? Is 5 divisible by 3? No. How many times can 3 go into 5? So we get x. Then we have the cube root of how many are left over?
2.
So however many times it can go into, it goes on the outside. Then on the inside, it's how many are left over. So if we do 3, or the cube root of x to the 7th, okay, how many times can 3 go into 7? Okay, and how many will it have left over? Oh, wait. How many times can it go into 7? There we go. Confused myself there for a second. All right, one more. If we have the cube root of y to the 11th, okay, how many times can 3 go into 11?
3.
Okay. And then how many would be left over? Okay. So we're going to go ahead and look at 44 together. Okay, for 44, we have 2 pieces of this. We have the cube root of 300 and the cube root of y to the 4th, okay? You cannot take the cube root of 300. You can divide it by all of those perfect cubes and not a darn one of them goes into it, okay? So if that ever happens, you just leave it as the cube root of 300. All right, now, for the next part though, can 3 go into 4?
Yes.
Yep. And how many left over? Okay, so to write my final answer, I should write what? There we go. All right, so I'm going to let you finish the last 3 of those. And once you are done with those 3, I will have the answer up here so you can check, and then you have Delta Math.
Excuse me? Let's go. You ever worked on your own? Hayden, did you? I know, or are you just looking at the board?
You can go only going.
No.
Stop.
I'm not gonna lie.
Yeah, it's where.
It's also really smart.
Really?
Let me just write that.
It's fish. It's fish.
See?
Yeah.
Absolutely not. Never in my life.
Oh,
Right. Really now.
I swear.
Really now.
It's 3.
The cube root of 27 is 3.
What did you think? What about you?
Would not be me.
All right, now one last piece of information before you start working on your Delta Math. On Friday, we will have a quiz on the things that we have done this week plus tomorrow. So exponent rules and radicals.
Yay. What are we doing tomorrow? I'm thrilled.
Both of those things together at the same time
Oh, right.
That's awesome.
Wait, when is it?
on Friday.
So what's